Okay, so in your foldable, what you should be filling in says a rigid motion. It is a transformation that preserves length and angle measures. Translations, reflections, and rotations are rigid motions. This should be filled in at the top of your pink slip. Is a transformation that preserves length and angle measurements. These are rigid motions. Gentlemen, let's begin this copy down. Okay, two figures are congruent when one can be obtained from the other by a sequence of rigid motions. I'm highlighting what is going in your guys' blanks. Congruent figures have the same size and same shape. Angles with the same measurement are called congruent angles. Sides with the same measurement are congruent sides. So on Friday we kind of explored where we used the tracing paper. We kind of played around trying to see if we thought two shapes were the same size. Today we're going to be furthering that discussion because we're telling you that a rigid motion is part of our transformation. Whether you use translation, which was our slides, if we use reflection, which is our flipping, or if we did our rotations, which was our turns. Okay? The biggest thing I want us to make sure that we're understanding is the rigid motion meant that we did not change the angle measure. I did not change the length of the side. So I did not make the picture bigger or smaller or change the shape itself. Yes? Are we just skipping dimensions? No, that'll be the next day. It's kind of messed up in the notebook, in the foldable. So, here's what we're going to look at. The triangles below, if you look up here at my example, the triangles below are congruent. Other side conversations should not be happening. Okay, here's our two triangles. There's a number of ways we can tell that they are congruent. The corresponding angles of the congruent figures are congruent, meaning they are the same size. And you see that right here where they do this one and this one. They're saying they're the same size. C and F are the same size. Angle A to angle D. Corresponding sides of a congruent figure are also congruent. So if I tell you two triangles are congruent, gentlemen, I'm not going to keep stopping for you. If I tell you two triangles are congruent, that tells me that their angles are all the same measurement and their side lengths are the same. Now, when we write this out, and you'll have to do this today. Actually, I'm going to stay right here. The way we are writing it is when I said AB, side AB, in math, the way we identify it is you say between 2 points. So this was point A, this is point B, so you'd write AB with a line above it. That means line or side AB. And then they have this little symbol. What that is, it says equal, but it has that little part over it. It's telling me that these two are congruent, that they are equaling the same amount. So I can see right now, and they have these color coded for us, that AB is the same as DE. That BC is the same as E and F, and A to C is the same as D to F. A common error when writing a congruent statement, make sure you list the vertices of the figure in the correct order. have to make sure you do it right. So when I said A to B, when I went to this triangle, I want to go from D to E. I'm matching up the same angle with the same angle. So this part is in your foldable. So what I want you to do is you're going to look at this, and it says identify if any congruent figures in the coordinate. Identify any congruent figures in the coordinate plane. So we have 1, 2, 3, 4, 5 triangles in there. Are any of the triangles congruent? That's what I want you to determine, and you can work with your neighbors right now. I'm going to walk around. We need to find out if any of the two triangles are the same size, the same length, the same shape, angles are the same, that they just got moved either by sliding, flipping, or turning. Okay? So, do that quickly. I'm going to pause. Alright, so, are there any congruent figures in here? Brett?
Yeah. The F, D, E, and the B, and
Alright, which triangle did you say?
the one on the bottom left.
And what triangle? How would you identify that triangle?
As the, is it for like the third?
No, when we have this, we actually identify triangles. We'll say triangle, and you list what their 3 points are.
Oh, F, D, E.
Alright, so F,
Yeah.
D, E. Okay, so what triangle is that going to match up with?
P.
Alright, so right now we are saying that triangle F, D, E is congruent with triangle P, M, and N. The way we are saying this, Harrison, pay attention, you making paper airplanes. What we're saying here when we say congruent, we're saying they're the same size and the same shape. Now, Brett, what did they do to these two triangles to move them? How are they different right now?
They brought it up.
Okay, so,
Translated.
well, let's see. If we check this, and we're following along right here, I'm going to switch colors. So here's our two triangles. If I went from FDE, all I'm going to do is this point is going to go up 1, 2, 3, 4, 5. So that's going to tell me that I translated. Remember, translate's just that fancy word that means I'm going to slide it or I'm going to move it. I'm going to translate 5 units up. So I moved it 5 units up, and then I went 1 unit over, and 1 unit right. That is what we played with and experimented with on Friday about just copying something on tracing paper and then just sliding it or turning. We can see if I did this, this side, D and F, is 1, 2 units big, 2 units long. If I look at M to P, it's 1, 2. If I look at how F to E goes, it crosses right across those 2 units. D to E is 2, M to N is 2. Those 2 are congruent. All we did was slide. Yes?
A, B, and C, and J, L, and K.
Alright, so now we think we have another one. Say it again. Triangle.
A, B, C.
A, B, and C.
J.
Triangle A. Hold on real quick. B and C. To
J, K.
J, K, L. Now, what did they do to this triangle to make sure that they're congruent? Okay, if we did a reflection, this is awesome. There's more than one way to get there. I could have said, we took this triangle and we turned it. And if I would have turned it, we could have got to the same place and slid and translated. If I look at my reflection, that's one of the first things we did. If I look at my reflection, reflect And where did you reflect? Where's your line of reflection, Donovan? Reflect on x-axis. This is our x-axis. When we reflect on the x-axis, remember the important thing is your x stays the same, the coordinate. Your y-coordinate becomes the opposite. So what that means is if I look at these coordinates, this one was 2, 1. This is 4, 1. This is 2, 4. If I reflected on, not on the x-axis, my x would have stayed the same, but the y became opposite. Well, if I look at this, this point is 2, -1. This one is 4, -1. This is 2, -4. I look at the points, x's were the same. Yeah, the y's just became the opposite. So that one's absolutely perfect. That's good. Good job, Donovan. So it says you try. A triangle has the vertices. So I'm going to draw this in here. And let's use the screen. Let me erase these so I have just a little more room. Alright, it says a triangle has the vertices of 0, 4. So 0, 4, and they said that is x. Y is at 4, 4. Okay? And z is at 4, 2. Is triangle XYZ congruent? Is XYZ the same size and shape as any other triangle on that plane? Remember, this is why I'm giving you guys transparency paper. You don't have to understand this just by visually looking at it. If I can find my pen. Actually I need this on one sphere. If I look at this and said 0, 4, 4, 4, and 4, 2. Okay. If we've looked at this, you have a question, Donovan? Did I make a mistake, or you just? Okay, just hold on real quick. Okay. This is why you have transparency paper and how we use it. I put it on here. And I'm going to go back to this one so you guys can make sure it's on the recording. I put my transparency paper on. I trace my x and y axis. And there's the shape I'm tracing. Is there any other shape that it matches up with? Right there. It matched up with triangle QPNR. What did I do? If you visually look at this with me, what am I doing? Okay, I'm rotating. So we're not turning. We're not going to say turning. We're going to say rotating. Which direction did I rotate? I went left. So what's left mean? Counterclockwise. And how far did I turn? 90 degrees. So if I go back in here, and you should write this down on yours, I'm going to go ahead and say triangle X, Y, and Z is congruent with triangle Q. Oops, I'm going to do it this way. I'm matching up the points. So X, I'm going to go to R. So triangle R, Q, P. And the way we did this, rotated, counterclockwise (90 degrees). Now, a lot of parts to this. So, make sure that you're following, because I think this should be pretty simple. Dusty, give you one warning. This should be fairly simple using tracing paper. Line the stuff up, and I traced it. And I looked for what triangle could it match up with. I know it can't match up with that one. It's too big. Even if I reflected and turned, it's too big. If I try to match it up with the triangle down here, well, it's that way. I have to reflect and slide. No. Reflect and slide. Still too big and off. This is how we're physically being able to check these. This is why this unit should be fairly easy, is we can physically manipulate everything. We can see what is happening. So once again, all I did was, there was my original triangle. I went to this triangle over here. I rotated my paper 90 degrees counterclockwise, and they lined up perfect. If I would have said clockwise, I could have still said clockwise, but how many degrees would I have had to go?
270.
Very good. It would have been, here's 90. You add another 90, that's 180. And I'd have to add another 90, which would have been 270. Alright. I'm going to be giving you guys some transparency paper to work on your homework in a little bit. But we're actually almost done with this. This is what we're talking about, congruent. Biggest thing. Congruent means they are equal in size, shape, the angle, the side line. So if I look at this one, let's see if we can answer this. How did the red figure become the blue figure using rigid motions? We did not talk about rigid motions before. That's what we're talking about today. Rigid motion is a translation, reflection, or rotation. So, how can I get from the red to the blue? What do you think is something we could do? Am I going to be able to just slide it? Let's go with translation. Can I slide this red figure and get it to the blue? Donovan? Okay, good. Since I didn't have many people answer that question, that means that you need to be following us so we can get this. I can't just take this figure and I can't just slide it up and slide over, because it'd be facing the wrong way. So we would first have to be rotating it. Let me look at something real quick. I think this. Turn in your notebook. I'm going to come around with some of these. Right here in our notebooks, what we're going to talk about. Here are some tracing papers. I like that, Donovan, you were able to visually kind of look at your picture here. That's good. But you give one to Will. Okay. Trying this with us. Turn to this in your notebook. It says, lesson. Dusty. Bud.
Oh, we're on that.
here. It should be glued in. Who? Check a couple of us.
Yeah, how's your day?
Yeah. Alright. So, this is what I want to see. This is going to be our little participation grade part. Go. Looking at this. Alright, 2.4. Bert, do you not have it? Alright. Everyone turn in their notebooks. You should have it. Use your transparency paper. We should all be able to do this. Did you not get one? Well, did you get 2? Transparency papers? Alright. So, gentlemen, camper, focus up here, please. Alright. Dylan. So, here's what you should be doing right now. Put that transparency paper on top. You trace. Dylan, why don't you go work at the back of the table? That's the second time I've had to ask you to focus. So, I take my transparency paper. I'm tracing this. And I'm going to go ahead and trace my shape. And now, after you have traced this, go ahead and how can you rotate it, translate it, or flip it? Doggo partner, we'll come right back to it. Make sure you're on this.
Oh, you will.
For now, try to follow with what we're doing. Alright, let's see. Who can come up and physically move my tracing paper? Alright, Dusty, let's go up and do it. You can use mine, Dusty. The red's the bottom left one. Alright, looking at Dusty, let's see if he does this correct. What are you going to do, Dusty? Alright, so we just did it. Stop there. What's that move? What did he just do? Did he counterclockwise? Clockwise. He went right. So we're going to rotate clockwise 90 degrees. And now? Close. Except, Dusty, We are not going to slide at an angle.
Oh, that's right.
So let's put it back where it was. Go back to the original. Line up your coordinates.
Me?
Yeah.
Okay. Like where?
All right. Now, when we are here, what do I need to do, Donovan?
You need to transition up.
And how many up?
2.
All right, 2. Gentlemen, do we need to go elsewhere? I keep stopping because you guys are talking about other things. All right, I'm going to steal your spot. Good job. So, Dusty showed us the first step is to rotate clockwise 90 degrees. Then if I look at your points. This point and this point is here and here. So I need to translate up. So I'm here. I'm going to translate up 1 unit. The reason I noted the 1 unit is I'm paying attention from just one corner. I'm going to put this back again. Here is this figure's corner, the bottom left. So I want to get to the same X line as this one. So I'm going to translate up 1, and then I'm going to translate 1, 2, 3, 4 to the right. 1, 2, 3, 4. That would put our shape together. So I'm going to write here. I'm going to say first, rotate clockwise 90 degrees. 2, we translated up 1 unit. Translated, how many did we go? 1, 2, 3, 4. 4 units right. Okay, I want you to do the same thing with number 4 and 5. We're running out of time because we're taking a lot of time to pause because of discussions. Number 4 and 5. I want you to do the same thing. Use your tracing paper. You can look up at my board. The red one's on the bottom right, and on number 5, it's the top right. How can we adjust these? Ooh, I'm almost out of seconds. I'm going to get Starbucks out. Most of them. Okay, do number 4 and number 5. Figure one out. Ooh, just hold on to it. Let it come through forward. Gentlemen, I got you just Dusty. Turn around, do 4 and 5, please. Okay, we should be able to do this one already. How do I do number 4? Here it's on my translating paper already, or my transformation paper, tracing paper. Keep calling the wrong name. Will, what am I going to do? You can just tell me and I'll do it. Okay, so well, we're going to go from this bottom one, so it's going to be kind of backwards. So are you translating, rotating, or reflecting? Okay, so we're going to translate, which means to slide. Which direction?
5 up.
Okay. I'm going to go 5 up. 1, 2, 3, 4, 5. You translated up 5, 3 left. 1, 2, 3. Perfect job. Translate up 5 units, translate left. Okay, last one. Red triangle's on the top right. I take my tracing paper again. How do I get from the red triangle to the blue? Sydney? Okay, rotate what?
270.
Clockwise or counterclockwise? Alright, so turning left? Or right?
Right, I think. I don't know. One of them.
Do you want me to turn this way?
Yes, 3 times.
Alright, so that's 1, 2, 3.
And then translate left 1 unit.
Pay attention. We have rotated clockwise 270 degrees. And then you want me to translate what?
Left 1 unit.
Left 1 unit.
And then down 3.
Oops, I think I was off 1. Hold on. Okay, then 1, 2, 3. Perfect. Alright. Here's what I'm going to have you do for your homework. You are doing congruent figures, day 2. Remember, Dusty, because I know the two houses are identical, they're congruent, their side lengths and their angles are the exact same. Use the 2 pictures to answer A, B, C. On number 18, 2 constellations are represented in the figures in the coordinate plane. Are the figures congruent? It's yes or no, justify. You have to tell me how. It's only 4 questions for your homework tonight. Okay?